Welcome to this lesson on nonpolar covalent bonds, a fundamental concept in chemical bonding. In this video, we'll explore what happens when electrons are shared equally between atoms. Nonpolar covalent bonds represent one of the purest forms of electron sharing in chemistry, and understanding them is essential for grasping molecular behavior and properties. A nonpolar covalent bond is a type of covalent bond where electrons are shared equally between two atoms. This equal sharing occurs because both atoms involved in the bond have identical or nearly identical electronegativity values. Electronegativity is the ability of an atom to attract electrons toward itself in a chemical bond. When two atoms have the same electronegativity, neither one can pull the shared electrons more strongly than the other, resulting in a perfectly balanced sharing arrangement. To determine whether a bond is nonpolar covalent, we look at the electronegativity difference, represented by delta En. Nonpolar bonds form when this difference is less than 0.5. The Greek letter delta represents change or difference, E stands for electronegativity, and N represents the specific element. When the electronegativity difference between two atoms is very small or zero, the electrons spend equal time with both atoms, creating a nonpolar covalent bond. The most common examples of nonpolar covalent bonds occur in diatomic molecules made of identical atoms. Hydrogen gas, H2, has an electronegativity difference of 0.0 because both atoms are hydrogen. Similarly, oxygen gas, O2, nitrogen gas, N2, and chlorine gas, Cl2, all exhibit perfect nonpolar covalent bonds. Since each molecule consists of two identical atoms, the electronegativity difference is exactly zero, making these textbook examples of equal electron sharing. The reason electrons are shared equally in nonpolar covalent bonds comes down to electronegativity. When identical atoms bond together, they have exactly the same electronegativity. This means neither atom can pull the shared electrons more strongly than the other. The result is that electrons spend equal amounts of time with both atoms. Think of it like two people of equal strength in a tug-of-war. When both have identical pulling power, the rope stays perfectly centered between them. In a nonpolar covalent bond, the shared electron pair is positioned symmetrically between both nuclei. Let's visualize this with a hydrogen molecule. The two electrons forming the bond sit directly in the middle of the two hydrogen nuclei. Because the electrons are shared equally, there is no charge separation in the molecule. Neither end of the molecule becomes partially positive or partially negative. This symmetrical distribution is the defining characteristic of nonpolar covalent bonds. Nonpolar covalent bonds have several important characteristics. First, they feature symmetrical electron distribution, meaning electrons are evenly spread between the bonded atoms. Second, no partial charges form on either atom because the electrons aren't pulled more toward one side. Third, molecules containing only nonpolar covalent bonds are nonpolar overall, which affects their physical properties like solubility. Finally, these bonds have no dipole moment. A dipole moment occurs when there's charge separation, but in nonpolar bonds, the symmetry prevents this from happening. To summarize, nonpolar covalent bonds involve equal sharing of electrons between atoms with identical or nearly identical electronegativity values. This equal sharing results in no charge separation within the molecule. The electrons remain symmetrically distributed between the bonded atoms, creating a balanced, nonpolar bond. Understanding nonpolar covalent bonds provides the foundation for learning about polar covalent bonds, which we'll explore in the next lesson. Thank you for watching.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.